Here's an introduction to graphing y equals sine of theta. This is a bit of a step up in sophistication. We're looking at the sine function as not just a single ratio in a triangle, which is the way you thought of it last year. And we have a new interpretation already, which is that if I have an angle theta in a circle, here's a unit circle. Don't worry about the fact that it's at -2. I had to put that for other reasons. And we have this point on the unit circle at a certain angle, then it's the height of that point. So here would be about, a little under 0.8. But we want to go beyond that. It's not just the height of a single point on the circle. We want to use the fact that this is a function. We can make theta anything we want. And we want to think of it as a function. And one of the ways we understand functions, not the only way, but a good way to understand it, is do just a standard graph of the function. So on these axes here, this is going to be the angle theta, and in the book that's often called t at this point. And this is going to be y, which we're going to use as sine theta. Now, here's a thing that it can be very confusing. I'm specifically not calling this axis the x-axis because we're often interested in taking this theta, and we've identified x, the x-coordinate of this point, with the cosine of theta. And later on, when we're confident with it, we can talk about cosine of x or sine of x as if x is a good variable to use for the input of this. But it's really better to remember that the input of a sine or cosine function is going to be an angle, and use a special letter for that at this point. Okay. So let's see what this should look like. There's a couple ways to think about it. We could just look at the table of values, and we'll do that in a minute, but I think it's more interesting to use the dynamic geometry first. And what I've done here on the sketchpad is when I move this point, what I've set it up is that the x-coordinate of this point A is automatically linked to this angle. And that's actually already all the weirdness here. There's going to be two pictures that we both want to memorize and understand of sine and cosine. One is where the angle really shows up as an honest-to-God angle in a circle. And we think of the x and y as the height and the horizontal coordinate, the cosine and sine as horizontal and vertical coordinates of the point. But when we graph in our normal way, we don't use angles. It's not about angles. We take a point. The input should be the horizontal distance on our graph. So that's the weird link here, is that I have to take like angle pi over 2. If it's pi over 2 on the horizontal axis, that corresponds to making a point with angle pi over 2 here. If it's pi on the horizontal axis for our graph, that's going to correspond to, okay, make an angle of pi on the circle. Now remember, I'm doing everything in radians. When we graph these guys, we almost always graph them in radians. They're better than degrees for most things. Okay, so for example, pi over 4 would be about 3/4, would be right around here. Pi over 3 is around, pi over 6 is around 1/2, would be here. Okay, so that's the link here, as how I'm making this sketchpad work. And what it's set up to do is as I vary theta, and then the sketchpad, I secretly set it up so that theta would appear here, all it's doing is it's plotting the point on the unit circle, and then we're taking it across and just plotting a point of the correct height right over A. So for example, since sine of pi over 2 is equal to 1, that means that if I have theta on this axis being pi over 2, I should graph 1. I should graph the pair pi over 2 comma 1. Okay, so that corresponds to the entry right here on the table, that if theta is pi over 2, sine theta should be 1. We're starting to memorize those. We're getting better about them. We know that's a true fact. And we're just plotting the point pi over 2 comma 1. And the great thing about this is that this shows me roughly what's going to happen. As I increase the theta angle, the sine is going to go up and then down and then back up. It's going to be positive and negative. And what I can do here is I can trace this point. And it's going to give me a picture of all the different possibilities. Let's start from 0. So it goes up. Pi over 2 is where its sine is biggest. Pi is where it's 0. Then it starts going down. When you get to 3 pi over 2, right around here, about 4.5, a little bigger. Then sine is at its minimum that it can ever be, is -1. We've talked about how sine is always between -1 and +1. Then it comes back at 2 pi, about 6.3 to 0, and then it repeats. Theta can be bigger. We talked a little bit about coterminal angles in a previous video. Theta can be any number it wants to be to indicate many rotations. So here theta is like about 8. That's a full 2 pi plus a bit. And in fact here this would be 5 pi over 2. 2 pi, which is 4 pi over 2 plus an extra pi. 5 pi over 2 corresponds to something about a little less than 8. And this is going to repeat forever and ever. Okay. I would try to scale it down and do it, but I think something might screw up if I scale it. I'm pretty sure. Sketchpad is not very good for scaling, unfortunately, or zooming. Now, what about negative angles? I don't have a lot of room here with this picture, but with negative angles, sine of like negative pi over 4, about negative 3/4, like here, oh, that's negative root 2 over 2, about -0.7. And if I go down even further, let's see if it works. It still works. I get to where sine of minus pi over 2 is equal to -1. And we've talked a little bit about the even and odd nature of sine. This graph isn't the ideal one for that, but what we're starting to see is a hint of the odd symmetry, the origin symmetry of the sine function. Okay, that's a good place. Oh yeah, and then if we wanted to be really careful, let's go back to the table and just check a few more table values. Like, oh shoot, I can't see them both at once. Well, I don't think I want to minimize that. Let's just look at it. 3 pi over 4, that's about 9/4, 2 1/4. Oh, that's about where I am right now. It should be root 2 over 2, which is about 0.7. Okay, let's see. Let's make that look like a roughly 45-degree angle. Okay, yeah. So that's about 9/4, roughly. That's 3 pi over 4. And here we are at about 0.7. So all these points that we could get off of the table show up on the graph. Notice that when theta is between pi and 2 pi, we get all these negative values. Negative and then more negative and then coming back to 0. I won't do every one of them because it gets boring.